Next up, we move up to the magnetic effect of a current. So this is the first thing which is interesting. Okay, now any wire, okay, that has a current, it actually has a magnetic effect. So magnetic field lines produced by electric currents are formed in concentric circles. First up, you must know that current produces a magnetic effect. So how is the magnetic effect like? Okay, they are in a concentric circle around the wire, with the wire in the center. Okay, so you can see here, the wire in the center, the magnetic field is like this. 1, 2, 3, 4, 5. Okay, you see the magnetic fields here. Now, you can see specifically when the current is going upwards, the magnetic field is going in a clockwise manner. How are we able to determine this? It's actually by this thing called the right-hand grip rule. Okay, so using the right-hand grip rule, we can actually determine the direction of the magnetic field produced due to the direction of the electric current flow. So now, let's take a look. So for example, if my current is going upwards, okay, so my thumb will point up. Now, take note the thumb will point along the direction of the current. Okay, so if comparing the two pictures here, if the current is flowing upwards, my hand will grip in such a way that my thumb is pointing upwards. Take note, it must use the right hand. So the thumb point outwards. Now, how do we determine the magnetic field? We look at our fingers. You can see that the fingers are going in a clockwise direction. So our magnetic field is in a clockwise direction. So by setting the right hand grip rule, we know that the thumb tells us the direction of current, the fingers gives us the direction of the magnetic field. So this is how we can determine the direction of magnetic field given the current flow. So do take note of this, and one pattern I need you to realize, okay, is that you realize the circles inside are closer together, whereas the circles outside here, they are further apart. Okay, this is because the magnetic field nearer to the wire definitely is stronger, and when it goes further and further away from the wire, the magnetic field actually gets weaker. So we say the strength, okay, how do we indicate the strength is actually by the spacing between the magnetic field lines. So you can see circling, okay, when the direction of current is reversed, so all you need just do is just flip your hand the other way around. So your thumb pointing downwards, okay, and your fingers, it will be looking like this. Okay, sorry for the ugly drawing, but you get the idea, right? Now, so when the direction of current is reversed, direction of magnetic field will be reversed too. Just use your right hand grip rule and you can try it out. Okay, now, this is one thing I need you to take note. Sometimes in a diagram like this, they use a dot to represent the current coming out of the paper. They use a cross to determine the current flowing into the paper. Okay, so you can see here, okay, this is not really so well indicated. Let me try to draw it. So there's actually a dot here. Okay, this is actually a dot. There's actually a cross in the middle here. It's not really very clear on my notes, but then it should be quite clear on yours. You should be able to see the dot and the cross. Now, the dot means the current is flowing out of the paper. So what you'll do is you place your hand with your thumb pointing towards you. Place the base of your hand, okay, on the paper, and then with the thumb pointing out of the paper. You realize that, oh, my fingers are pointing in a anti-clockwise manner. That's why you can see the magnetic field is an anti-clockwise direction. Okay? For this case here, a cross means the current is going in. So you take your thumb and point down and realize the magnetic field is in a clockwise direction. So this is how we can determine by using the right hand grip rule. Okay, this is for a single conducting wire. A right hand grip rule. I use this for the single conducting wire. So as indicated here, the magnetic field is strong in the region near the wire, okay, but then it weakens with the increasing distance from the wire. So this part here I've also explained it already. Now, this is one interesting thing here. Okay, the larger the electric current, the stronger the magnetic field strength. So you want to make the magnetic field strength stronger. Okay, you want to make the circles looking more concentrated, or more and more circles. What you can do is you can increase the current. It will increase the magnetic field strength. Okay, so main concept here, we need to know that moving electric charges, which is your current, okay, produces a magnetic field. So this is a thing that you must remember. Okay, this is a note here. It is that many students always fail to show increasing distance between concentric circles. Okay, because remember I saying the magnetic field is strongest in the center and weakest out further away from the wire. So you can see it's closer, it comes further, further, and even further apart. So this is one thing you must take note of. Okay, now, so we are done with this part here. We talk about the magnetic effect of a single conducting wire.